First, you had to suffer through Mr. Brust. Sure, he was the 2012 District Teacher of the Year. Shaking someone important's hand right there. Then you had to put up with Mr. Kelly. Yes, very esteemed Mr. Kelly, 2010 Presidential Award for Excellence in Teaching Mathematics. Between two important people no one knows. But now, the moment you've all been waiting for, you get this guy. Yeah, sorry about that. But I'm back, baby. Alright, so first thing we're going to do, we got some definitions. You know how those work. Write these down while we talk about it. You probably want to pause the video after you've written them down so that we can actually talk about it a little bit, alright? First one is parallel lines, and those are lines that are coplanar lines that do not intersect. So coplanar, remember, it means they have to be in the same plane. If they're not in the same plane, they technically cannot be parallel lines. Now that's tricky because if we have a figure over here, we have this cube, right? We have this line here, AD. Okay, now AD would appear to be in the same plane as BC, which it is. And since they're coplanar and that they never intersect, they are in fact parallel. And if you notice, we mark parallel lines with these arrowheads. So AE is also parallel to BF. And since those are parallel to each other, we mark them with one arrowhead. Up here we marked AD and BC with two. That way we can distinguish between the fact that they're different, all right? They're not parallel to each other. AE is not parallel to AD, okay? Let's see. AD does not touch BF. AD does not intersect BF, right? However, they're not in the same plane, okay? Remember, a plane is like a piece of paper. So this piece of paper is not the same piece of paper as this one. They're not in the same plane. Sure, one point is, but not all the points of that line are. So therefore, we can't talk about those as being parallel. Well, those are called skew lines. And those are non-coplanar lines. They're not parallel and they do not intersect. So since they are not in the same plane and they don't intersect at all, then they're skew. Now take a look at this. AD and AE. Again, they're not in the same plane. They share a point though, don't they? One point is in common, so they're not skew, okay? And then the last one is parallel planes, and parallel planes are planes that do not intersect. So if you have this plane down here, EFGH, it's parallel to ABCD. They do not intersect, all right? You could also see this plane at the front of the cube, right? And we'll talk a little bit more. Let's get a little bit better picture of that. Oops. Here's a Rubik's Cube, right? This front, this red face is a plane, and the top is a plane, and this side's a plane, okay? Now, if I take this right here, okay, let's even draw that. If I take this line, and right, and this is also in the same plane, bad drawing, Mr. Sullivan, they don't intersect, therefore they would be parallel, okay? However, if I took this line here, boom, and this line here, now you can see this green line here is in the yellow plane, all right? It could also be on that backside plane, but is it in the blue plane? No. Or the red plane? No. Therefore, those are skew lines, okay? They're never going to touch. They're not parallel because they're not in the same plane, okay? Look at this one. If I drew this one in with this one, they're parallel. We would draw an arrow on there to label that we know that they are parallel, okay? There's no markings for skew lines, but they have that one for parallel lines. All right. A transversal. A transversal is a line that intersects two or more coplanar lines. So I have a line here and a line here. My transversal cuts it right through the middle. All right, it cuts through both lines. All right, and as you can see, if you have two lines, you have an outside and exterior, and you have what's between the two lines, also known as the interior. Okay, and this line that cuts through them both is called the transversal. All right? All right, so again, if I were you, I would copy these down. Then let's talk about them. So you might want to pause it and copy those down. All right, so the first one now what we have here are very special relationships. And we need to know them by name so that we can talk about them. We're going to talk about them a lot this chapter. The first relationship we have are alternate interior angles. So interior, you know, it's going to be between the two lines, right? So if R is my transversal, it cuts between two lines. My interior is here, and then my exterior would be out here or out here, okay? So non-adjacent interior angles that lie on opposite sides of the transversal. So let's take a look here. Let's say I have 2. That's on the interior, and it says opposite sides of the transversal, but inside. So opposite of this, and it also says non-adjacent. These are right next to each other. That's adjacent. So 2 and 6 are alternate interior angles. What's another set of alternate interior angles? 7, opposite 7, but not adjacent would be 3. So 7 and angle 3 would also be alternate interior angles. Okay? All right, next one, same side interior angles. Same side interior angles. These are interior angles that lie on the same side of the transversal. So down here, 2 is on the same side as 3. Here again, here's our transversal. 2 and 3 are on the same side of that transversal. Don't get confused and think N or M is our transversal. R is our transversal, because it cuts through 2 other lines. All right? So 2 and 3 are same side interior angles. So are 7 and 6. All right? Okay? Corresponding angles. Corresponding angles lie on the same side of the transversal and in corresponding positions. This is kind of tricky. All right? So let's take one here. All right. So you can see this is a group and this is a group of angles, right? This group is formed by the transversal and M, and this is the transversal and N. So 1 would be in the upper left position here. What is in the same corresponding spot over here? 3. So 1 and 3 are corresponding because they're both in the upper left-hand position. How many corresponding angle pairs do we have? We have a bunch. 2 upper right because it corresponds to 4 upper right. 8 lower left, 6 lower left. So 8 and 6 are corresponding. And then last but not least, 7 and 5. 7 and 5 are both in the lower right, so they'd be corresponding. Okay? All right. Let's look at the last one. Alternate exterior angles, non-adjacent, so they can't be next to each other. Exterior angles that lie on opposite sides. So these are all exterior, so they got to be on the outside. So 4, 5, 1, and 8, those are the ones we're talking about. Let's look at number 1. If one's on the top side, it has to be on the opposite side, so the opposite side would be 5 because it cannot be adjacent. Remember, adjacent's right next to it. So 1 and 5 would be alternate exterior angles. 4 and 8 would be alternate exterior angles. All right? So let's go back and let's just label a few of these. So angle 4 and angle 8, those would be alternate. That'd be an example. Corresponding, let's say angle 1 is in the same position as angle 3, so those are corresponding. Same side interior, 7 is on the inside and it's on the same side of the transversal as 6, so that's an example for 7 and for same side. And then alternate interior, so let's say 2 and opposite side, 6. So angle 2 and angle 6. All right? That's a lot of them, I know. All right, so I want you to right now pause this and try and answer these questions the best you can. All right, so we need to name one pair each of the segments, planes or angles, lines and planes that appear to be parallel are parallel. All right, so it appears that this is a box, so it looks like all these lines are parallel. So we're going to have a lot of answers, okay? You could have a ton of these. Let's take a look. Parallel segments. I know that EA, so segment EA is parallel. This is our shorthand. Parallel looks like two lines straight up and down. EA is parallel to HD, segment HD. All right? Well, it's all, HD. You could also draw these on here. You could have had HD as parallel to GC, FB. You see there's a ton. EH, AD, DC, HD. There's a ton here. There's absolutely a ton. Skew segments. So let's find two segments that are not in the same plane and never intersect. So let's see. Let's start with FG. All right, so FG. And remember, we don't have any shorthand for skew. I write this is like plus, that's an and. So FG, and let's see. What's not in the same plane? All right, well, this is not in the same plane, and it's going a different direction. That's HD. HD. All right? Now, some of you are going to say, well, FG and AD, they would appear to be not touching and not in the same plane. But you have to imagine, there's a plane that goes through there. It may not be drawn, but it's there, right? It's like a single sheet of paper that slides in through there, okay? So two parallel planes. Well, let's see. Let's answer that one over here. I'm going to go to the top, so we'll say plane. Oh, awful handwriting. EFGH, EFGH, and ABCD. Plane ABCD. All right, you could add any of them. This side EFBA and HGCD. There's a lot there. All right, down here now we're doing alternate interiors. So let's see, interiors between the two lines. Again, here's our transversal because it cuts through two lines. So our alternate interior, if I have 3, would be 2. So there's one example right there. So angle 3 and angle 2. The only other one you could have had was 8 and 6. Same side interior. Let's do 3. So angle 3, and what's on the same side of the transversal? Angle 8. The other pair you could have had, because it has to be interior, is 6 and 2. Corresponding, let's start with 5. So angle 5 corresponds to angle 8. You could have had angle 3 and angle 1. You could have had angle 4 and angle 2, or angle 6 and angle 7. And then alternate exterior, let's say 5, it's going to be on the outside, and opposite side of the transversal on the outside, 7. The only other pair there would have been 4 and 1. All right? I know that's a lot of definitions. It shouldn't be that hard. It's kind of, just seeing stuff, all right? Not a lot of work to show necessarily, just a lot of stuff you have to look through and see. So take a minute, and maybe you'll find this clip funny, maybe you won't. Good luck on Chapter 3.
All right, Barry, are you ready?
I am, Eddie.
The question for $1 million. What is the first letter in the English alphabet? Is it A, C, B, D, C, A, or D, B? What is the first letter in the English alphabet?
Well, it's A, isn't it?
I don't know, mate, is it?
Well, yeah.
So you want me to lock that in?
Yes, please, Eddie.
Lock in A.
Yep. Oh, well, hang on. What I mean is C.
C?
Yeah.
First you said A, and now you want to change it to C. Well, what do you want me to lock in?
Oh, no, the answer is A, so lock in C. C, A.
C, A. I need an answer, mate.
Yeah, no, lock in A.
So that's your answer?
Yeah, A is my answer.
Okay.
So you're locked in C?
Oh, listen, mate, you can't have it both ways. Either I lock in C or I lock in A.
A.
So you want to lock that in? Lock in A?
Yeah. A, as in C. No.
Well, can you just give me the straight answer so I can lock the bloody thing in?
The answer is A.
It's locked in.
So you're locked in C?
Shut up. Well, $1 million. What is the first letter in the English alphabet? You said A.
Meaning C.
The answer is C. A is the first letter in the English alphabet. Sorry, Barry. We're unfortunately out of time here on Millionaire, but we'll see you next time, eh? It's not that hard, isn't it?